Hello everyone, today our group will explain about linear search and binary search. But before that, let we introduce ourselves first. Starting with me, I am Ikamadi Viryanto Karang. I will explain about linear search. Here I will explain what it is linear search. Linear search is a simple searching algorithm that sequentially checks each element in a list until the target element is found, or all elements have been checked. Next, performance. Time complexity O n, where n is a number of elements in the list. Space complexity O 1, because only a few variables are used for iteration. Next, algorithm. First, start from the beginning of the list. Second, compare each element with the target elements until a match is found. For the end of the list is researched. Next, example. Searching of an element in an unsorted list. 5, 3, 8, 4, 2. To find if 4 exists. The binary search material was explained by my friends.
Binary search. Binary search is an efficient searching algorithm for sorted lists. It repeatedly divides the search interval in half until the target element is found or the interval is empty. Performance. The complexity 0 log n, where n is the number of elements in the list. Space complexity 0i, since it uses interactive approach. Recursive would use 0 log n space for the recursive type. Next, algorithm. Number 1. Compare the target element with the middle element of the list. Second, if the target matches the middle element, return the index. Third, if the target is smaller, continue searching in the left half. Fourth, if the target is larger, continue searching in the right half. Example. Searching for an element in a sorted list. 2, 3, 4, 5, and 8 to find if 4 exists.
So now we'll dive into understanding the linear search algorithm implemented in Python. Before that, linear search is a simple algorithm that searches for a target value in a list sequentially. Now let's break it down the Python code. In Python, the linear search function is a straightforward algorithm used to find a target value x within a list, this list. The function iterates through each element of the list using a for loop and compares each element to x. If a match is found, it returns the index of the first occurrence of x in the list. If no match is found after iterating through all the entire list, it returns -1. This approach is efficient for small dataset or unsorted lists with a time complexity of 0n, where n is number of elements in the list. For example, searching value 5 in this list. Now let's run this code, and as we can see, successfully identifies 5 at index 4. This illustrates the simplicity of effectiveness of linear search and basic searching tasks, providing a fundamental understanding of how algorithms traverse and identify elements within data structure. Now let's dive into the binary search algorithm implemented in Python. So Binary search is an efficient algorithm for finding a target value within a sorted list with repeatedly dividing the search interval in half. Now let's explore the code and understand how it operates. In Python, the binary search function implements the binary search algorithm, which efficiently finds a target value x within a sorted list in this list. The function begins by initializing low as the string index of the array, which is 0, and high as the last index, which is blank array minus 1. It iteratively narrows down the search range by calculating the mid index using integer division of the sum of low and high by 2, depending on whether the middle element, array mid, is less than, greater than, or even equal to x. It adjusts the search bound, low and the high. If array mid is less than x, it sets low to mid plus 1 to search upper half of the remaining array. If array mid is greater than x, it adjusts high to mid minus 1 to search the lowest half. If array mid equals to x, it returns mid, indicating the element x was found at index mid. If the loop concludes without finding x, the function returns minus 1, indicating x is not present in the array. The provided example demonstrates the function usage on the sorted version or an unsorted list, showing how binary search effectively finds elements in sorted array. In this part, we'll explore a Python function designed for linear search to retrieve employee information based on their unique ID. The function named by a linear search employee is straightforward. It iterates through a list of employee dictionary and compares each employee's ID to a specific target ID. If a match is found, the function returns the corresponding employee dictionary. Otherwise, it returns not found. This approach is effective for small to medium-sized dataset where simplicity in implementation is prioritized over search efficiency. Let's examine our example dataset to understand how the linear search function operates. The employee list consists of dictionaries, each representing an employee with attributes like ID, name, and position. For demonstration, we have predefined employee with several entries, and we have set target ID into this one, indicating our interest in finding the employee with this specific ID. We now execute the linear search employee function using our example dataset. Upon calling the function with employees and target ID, it performs a linear search through each employee dictionary to check if their ID is matched with this ID. Depending on the result, if a match is found, it prints the employee's name and position. Otherwise, if notifies that the employee with this ID was not found in the dataset, it will be not found. Let's delve deeper into how the linear search employee function operates and implication. The function purpose is straightforward to locate an employee's information based on their ID. Within the given list of dictionaries, it iteratively compares each employee's ID until it finds a match or exhausts the dataset, returning the employee's detail if it found or none if not. This method showcases a basic yet effective approach for searching through unsorted or small datasets.
Thank you for listening to the material we present. If there are any wrong words, please forgive me. That's all for us. Thank you.